Now for question number 1, enter the value of p so that the expression 3 parentheses 4 plus n is equivalent to 3 parentheses n plus p. Now for question number 1, when we're looking at this type of problem, we know that since they give us 3 on the outside, we already know that it matches the 3 on this outside. But then we look that the n on the inside matches the n on this inside, except that they switched locations. And that just simply means they used the commutative property. They just switched the number and the variable. And then if you notice, the only thing that's missing is the number 4. So in reality, p equals 4. And it would make the same result. So if I put them equal to each other, 3 parentheses 4 plus n, it is equal to 3 parentheses n plus 4. They would be the same exact thing, except that the inside switch, which means it's just the commutative property that used that to switch the numbers. Now for question number 2, select all expressions that are equivalent to 2x plus 3x plus 8 minus 3x minus 2. Make sure you pay very close attention to all possible solutions. So now I have 2x plus 3x plus 8 minus 3x minus 2. So I can combine like terms. I can combine 2x plus 3x, which gives me 5x. Then I can combine the negative 3x, and that gives me 2x. Then lastly, I take the positive 8 and I combine it with the minus 2, and that would give me a positive 6. So I know that 2x plus 6 is a solution, so that is correct. The second one, 2x plus 10, that would not be correct. Then if I go back to what I originally had and I look at the information, the 2x plus 3x, that gave me 5x. But if I would have kept the minus 3x and just combined the 8, the plus 8 and the minus 2, that would give me a positive 6. So then this 5x minus 3x plus 6, that is also a true statement. But the last one, 5x minus 3x plus 10, that would not be correct because 8 minus 2 is 6, not 10. So the first and the third are the correct solutions. Now for question number 3, it says enter the number that makes the equation 0.76 plus 24 over 100 equal blank over 100 plus 24 over 100 true. So the first thing I want to do is take the 0.76, and I realize the 6 is in the hundredths place, so 76 over 100, and then that ends up being our missing solution. Now for question number 4, select all expressions equivalent to 6x minus 24. So in this case, we have to look at all possible expressions, so some of them may be correct, some of them might not be correct. Now the easiest thing to do is divide out the 6, because we know that 6 can come out of both of those values, so 6 times x minus 4. And it's technically doing distributive property backwards. So we know for sure that the first one is a correct solution. Another way we can look at this problem is by simplifying it with a smaller value. So for example, if I wanted to erase the divide by 6 and I want to divide it by something else, so say I want to divide it by the number 2, then I would have the 2 come out, and that would leave me with 3x minus 12, because 24 divided by 2 would be 12. So I'm double checking to see if any of those are the possible solutions. So that's not a possible solution at all. So I'm going to erase that, and I'll try a different number now. So now instead of dividing by 2, I can divide by 3. So now 6 divided by 3, so I can take out the 3, and it leaves me 2x minus 24 divided by 3 would give me 8. So another solution would be this third one. Now the last two that are remaining, I know that I can distribute. So here 2 times 3x would give me 6x, but then 2 times negative 24 would give me negative 48. And it says negative 24. So this is not a correct answer. And then for this one at the bottom, 3 times 3x, that's 9x. And we know that it starts with 6x. So that is also not a correct solution. So the only two correct solutions are the first and the third. For question number 5, select the expression equivalent to negative 2x plus 8.1y in parentheses minus negative 9x plus 5.3y in parentheses. So make sure you check all possible solutions. To evaluate this problem, what we would first do is take the negative 2x plus 8.1y, and we will keep that the same. But then we realize that this is a negative, so we're going to distribute the negative. And negative times negative 9 would be a positive 9x, and then negative times a positive 5.3y is going to give us a negative 0.53y. So now I want to combine like terms. I'm going to take the negative 2x and I'm going to add it to the 9x. So negative 2x plus 9x would give me positive 7x. And then I'm going to go ahead and take the positive 8.1y, and I'm going to subtract the 5.3y. So in this case, I have 8.1, and I'm going to subtract the 5.3, and I end up with a positive 2.8y. So now when I'm looking at each possible solution, the only one that makes the most sense is letter D. Now for number 6, select all expressions that are equivalent to 5x plus x plus 6 plus 3x. So in this case, we know that you have to check through each possible solution. So make sure you look at all 4 choices and pay very close attention. Now for 5x plus x plus 6 plus 3x, we can actually combine like terms. So in this case, I can combine the 5x plus x, which would give me 6x, because this is 1x, plus 6 plus 3x. So we already know this second one is a possible solution. That is correct. Now another possible solution is if I add the 6x and the 3x, and I get 9x plus 6. That is also a possible solution. So that is also correct. Now, the first one, 8x plus 6, that is not true because it is 9x plus 6. And then finally, the 5x plus 6 plus 3x is also not true because we have the 6x plus 6 plus 3x. So we combine like terms at the beginning, and then we simplified all the way at the end. Now for question 7. Tracy had a total of $200 to spend while shopping. She has already spent $134 on clothes. She wants to buy some video games that are on sale for $20 each, including tax. Enter the maximum number of video games Tracy can buy with the remaining money. So in this case, you will have to round your answer to the nearest whole video game. Now, we will take the $200 that she has the total to spend, subtract the $134 to see how much money she has left over. So in this case, she ends up having $66 left over. So we take our $66 and we divide by the $20 because we want to know, since each video game costs $20, we want to see how many of those video games we can get. So once we divide 66 divided by 20, we end up with about 3 video games. It's a little bit over, but we know that we need to write the maximum number of video games, so we do need to round it to the nearest whole video game.